And over my career, over the years, I've met with some of the greatest engineers that I've seen, and they were mostly women. And today I want to introduce you another one of them. You already know her. She's called Miri Minas out there. We are working together for about 2 years at UNU, and she is one of the coolest engineers I've ever seen. And she has an amazing contribution to the company. She started out as an iOS developer, native Swift developer, and then she's now doing JavaScript as a mobile application, and also went onto the back end. So went through all of these in a breeze, and she just kicks ass. So give her a huge round of applause.
I didn't prepare anything. I will just say about some stuff about my story, basically. So I studied computer engineering in Turkey, Istanbul, and then I worked as a Oracle developer for a while, and then I wanted to move to mobile applications because I thought I wanted to do something. Yeah. Okay.
Sorry.
So should I start from the beginning again? I'm Miri. I studied computer engineering like 10 years ago. I graduated from that, and then I immediately started at a corporate company about Oracle development, and that was, when you work at a corporate company, you can't do much personal projects, and because of that, I wanted to move to mobile applications. And then when I started, Android was really immature, so I tried Android development as well, but the emulator was taking so much time, and then I moved to iOS development. But for me, it's not important, like programming languages, that's just like a tool. Of course, JavaScript is a really good tool, so we are learning it, but in general, you have to have this mindset that like, this is just a tool, and you want to create something, and I can see that like here, many people, I can see from the projects, like everyone has their own small idea, and developing it, and it becomes bigger and bigger. So I saw that like someone is doing something about yoga, the other one is doing this library thing. So I think here we are on the same page on that. And what else I can say? Also, there is something else which is really important, I think, for everyone in this room. As Arman mentioned, the percentage of female in our working environment is really less. So, if there would be like 2 more in our office, it would be like 20% more. So, yeah, because it's like we are now like 10% in the team because we are 2 people. So, whomever goes out of this room and becomes a developer, a female developer especially, it will change the working environment and the statistics already, and it will affect the other people to have the courage to start this. So I think one thing which is really important for me why I'm here is that I think it is good to give something back to the society, and this is how I want to contribute. And I think whomever who is here, it's not like an individual personal thing anymore. It's more like you will be a role model, or you will also encourage other people, you will help them to learn something else on the next level. So that's all what I want to say. And I want to help you all. Another thing is like, don't be shy or something, just ask anything. Because you have to learn something here. The aim is that, and just try to get most out of it. That's all. Thanks.
Thank you. Yeah. So, okay. I can put that. So, thank you for your kindness. I wanted to invite Miri on stage because she is kind of a role model when it comes to inspiring everybody in the team, not only female developers, but everyone, because she basically does whatever you throw at her. Because I know some of you just are shy, hey, like this is too big, I cannot do this, I cannot deal with that, or I didn't understand that topic. That only happens on your own minds. That doesn't reflect reality, that doesn't reflect your understanding. You can do a lot more. Just try. And yeah, she's one of those brave people who never shies back from anything and can say, yeah, of course, I will do that. I will give it a try, give it a couple of days, learn it and do it. And she does it. So I wanted to tell you that, that personality is in everybody, so you can do it. Please try harder, and we are always out there on Slack. Please don't submit your homeworks on the last day, and give us a couple of days before to review your code and to improve on it. And please also look into other people's homeworks and code to learn and to suggest, some improvements. That would be awesome, actually. And yeah, that's how we will improve. As Miri said, you're all influencers right now. You're all role models for future candidates of development. So this is like a mission. This is like a common mission that we will all do together. And yeah, we need your support in that. Okay, welcome. I think I can start with today's topic. So raise your hands if you have ever written an HTTP server before, an API. Okay, 1, 2, maybe. Perfect. This is the right audience. We will start from the absolute beginning by actually simply demoing what we have or what we will achieve by the end of today. So this is an application that I developed that's already on GitHub. If you did the final step, if you did git checkout final and tried the code, you already saw it. Who tried it already? Good. Well, perfect. You actually were not supposed to try it, so don't feel bad if you didn't. It's something that we're going to do step by step. But the idea is this is an application that builds on top of what we have learned so far. We created a class called person. We made them friends, and we then introduced a database, a file database, and then we introduced asynchronous programming, right? And now is the time to actually make it into a web application and to access it over the browser. And this is what we're going to do today. So the URL is something like localhost 3000, and I will explain it a little bit in detail, a little bit more. But raise your hands if you know what localhost is. Cool, great. So let's start with Google. So when you want to go to a web page, you write its URL, right? Google.com. Unique resource locator is the long form. So you type it in the browser and it's an address. What happens is the browser asks that address to something called the DNS server. And raise your hands if you heard a DNS server before. Okay, that's smart, that's nice. It's some numbers that you enter into your operating system settings, like 8888, 8844 are one of the most common DNS servers. Basically, the responsibility of that thing called the DNS server is to tell on which machines, on which physical addresses those addresses are located. So you write google.de or google.com, the browser asks the DNS server and says, hey, like, the user wants to display this web page, but I just have this address. I don't know where it is located. Just tell me where it's located so that I can actually contact the original Google servers and fetch the homepage and display it to the user. And the DNS server says, well, it's like this address called something like an IP address, and raise your hands if you know or if you ever heard of IP addresses before. Good. Oh, that's great. So it gives you a number, an IP address. It's like an address, a physical address, like your street and your postcode, which defines a seemingly single computer on the internet. So once you have that IP address, you say, okay, then I will make a request to that IP address. And when you do that, when you make a GET request to that IP address, it gives you whatever document there is hosted. And when you do that for Google, you basically get back the Google homepage. So this is a miniature version of how things occur, how things happen. You type an address to the browser, it asks the DNS server, and then the DNS server responds back with an IP address. The browser then goes to that IP address and says, hey, give me this google.com or whatever that I want to display. And the servers of Google, in this case, sends back the homepage of Google for us so that we can basically interact with it. So, for example, you can go to another link, google.de/something. I just click the images, or click anything else. You see the URL here changes, and there is a new path. This is called a path. There's a new path on the URL for the server to understand what we actually want. So in this case, we want the privacy policy, okay? And the path includes policies/privacy, which is again a resource indicator for the server. Basically, we tell the server, hey, I want the privacy policy, or give me something, whatever there is on this link. And well, this time it responds back with this privacy policy page. So the idea is every web page is served by a server, and you communicate with that server over an IP address or a host name, something called a host name or a domain name. Google.de is a domain name, and there are several others actually, billions of other domain names out there on the internet. And every domain name actually maps to a real server that meets your requests. And this is what we're going to build today. We're going to build on top of our application previously, and it will be a web application. We'll be able to interact with it over the web browser. We'll be able to add records. We'll be able to remove records. We'll be able to list records and list details of people. And hopefully it will be a useful exercise. But this is how we move into the idea of a URL and a server. And then what is localhost? Localhost is your own personal computer, because what are you going to do when you want to develop something on your machine? You have to know the IP address of your machine, right? It's actually an IP address called 127.0.0.1. Okay, that is your IP address. And then for our application, we have something called a port. So you could write this, and this would also work, port 3000. But this number is hard to type, sometimes even hard to remember. So we just prefer to use localhost to refer to our own machines. So when you write localhost, if you have a web server on your own machine, you'll be able to see that. If you don't, you won't see anything. The browser will say, well, I couldn't connect to that site, that this site cannot be reached, because I don't have a web server listening on this this IP address, the server. So the communication between a web server and a browser actually happens over something called ports. Network ports, TCP/IP ports. Raise your hands if you know what ports are. Perfect. It's like, if you remember the first lecture, I told you that naming is hard in computer science. It's actually one of the two hardest things. And This time they got it right. A port is like a port in a city, like a port you have in a city where, you know, ships come and load cargo or unload cargo and take that cargo to another city and unload it there. It's basically a special mechanism that lets you communicate. Think about the ships that carry cargo between two cities as a communication platform, and they stop at ports or they start from ports, right? So every computer has 65,536 different ports. That's enough ports for everybody to communicate with all the servers they need in the world. And every connection that you create on your computer for another web functionality actually happens over a port, over a free port, basically. Every port can have one communication going on at the same time, and therefore, if you need more, you have to open more ports. Why am I telling you this? Because in order to connect to a web page, an IP address is not enough. A domain name is not enough. You also need a port, because ports are the only way you can unload your cargo, right? You cannot just dump it in the middle of the ocean. You have to have a port and unload it there. Therefore, you actually need a port. There is a standard port for all web pages, and it's 80, port 80. So anytime you type an address on your browser, like Google, you actually type, let's do it. Whenever I type google.com, I actually type google.com colon 80. And it gets redacted because everybody knows that it's the default port and it's unnecessary. So there is this communication standard, but there is a little problem. As users of your local computers, you cannot listen on port 80. In other words, you cannot make use of port 80. That is a limitation of the operating systems. They don't easily give you control over ports below 1000. So you have to use something else. You have to use a port above 1000. It's by definition some rule that some people thought was useful. And therefore, most of the web servers actually listen on port 3000 locally. And that's, I guess, a convention set or used mostly by Ruby on Rails developers. Correct me if I'm wrong, but that is the default port. You can use anything. You can use any number between 1024 to 65,536, but mostly people use 3000, 4000, 5000 or whatever. And basically you are free to choose which port you want to have your web server. And yeah, the default is by convention 3000. That's why I have to write 3000 here on the address to reach my local web server. Why? Because I'm not using the default port. I'm not using 80. I'm using a special port, a special number that I came up with, an arbitrary number. Therefore, I have to type it in the URL to access my own local web server. And actually here is an example. If you look at it, so we have localhost 3000 slash person slash all is a URL. And localhost is the domain name, 3000 is the port, and the rest is the path that I want to be served, that is transferred to the web server. Do you have any questions so far? Please. Sorry? This is the final branch in the code. No, just stay on master and we'll continue there. I just wanted to demo the final stage. But do you have any questions? Okay. So raise your hands if you think everything is clear so far. Cool. Some people are in doubt. So tell me, what is a little bit unclear? And let me clarify it for you. And it's perfectly okay. Again. Hello. How about you? Are you okay? Because you didn't raise your hand, like, it's all right. Okay, feel free to stop me anytime by raising your hand, and if you have any questions, I'll try to answer them. And also, again, I have a lot of friends here today to help us. Please make use of them, and that's the way they are entertained, by helping people. Okay, so this is how we reach our web server, and at the end of the day, we will get a web application that allows us to display the people in our system. And how we do that is, like, I set up a web server. We will do it together with you today. And that is the address, hello, and here are the people. And it shows you the people in my database, okay? Well, let me show you the database. So this is the database file that I have right now. This is what we did since kind of week 1, right? We had a database file, a JSON file that has an array of objects. So this is nothing new to you, hopefully. And I want the web application to display it as a web page like this. And it also logs it to the console. This is just a demo that I'm doing, and we'll be building this step by step. But I want to create a new person, all right? Now, I will talk about the syntax, but there's a library that I have included on this application that helps me create requests, do requests to my web server, and it is as simple as writing Axios is the name of the library, post, and I will talk a little bit more about that later, person, okay, name, Juan, and age 26. So, my server working? Oh, it does. So I edited it, I ran the code, I refreshed the web page, and I see it here. Again, this is the code that I wrote. I can create another one. And if you remember from last week, we can use then for promises. This actually returns a promise, and then I can use console.log, and it will give me the data that I received from the backend. And yeah, actually you can see that there's a new person, 5. And whenever I refresh the page, I see the list of people. So this already looks like a contact list, and below I just dumped the database, the raw form, so that we can double check. Let us delete someone. For example, I created duplicate Juans, and that's not what I want. I want to have a single Juan in my database, so I will just delete them. So I will do Axios delete person 4, for example, person/4. And it said, okay, that's good. I refresh it, and number 4 is gone. I will say Axios delete 5. Okay, it said, okay. I refresh it, it's gone. I have 3 people right now. So this is kind of, looks like a useful application already that you can interact with. It's a backend application that you can deploy to any server, make it available to anywhere else in the world, and this will be your homework. So you will be required to do a web server and yeah, and hopefully make a useful application to build upon what you built so far. But let's go to the details of a person. So if you notice the URL, I changed it from person/all to person/2, and that gives me a dedicated web page for this user. It's like a profile page, if you will, and gives me the whole details of Miri. If you say person/1, you get my details. If you do person/3, you get Juan's details. Does it make sense? Raise your hand if you ever saw something like this before. I bet you did. Everybody's using Facebook, right? Or Twitter. There are user profiles. Sorry?
I assume they're the whole
Like this? This is what I write to add people. But again, we'll cover this until the end. So this is the end result that we're going to get today. I just wanted to give you a glimpse of the future, if you will. But like, this is already useful. This is already something that you can give out to your friends and they can use. And obviously you can add forms, web forms, to make these requests automatically from those forms. And yeah, basically this is a working application, and we are at the end of week 4. We already have done something that's useful. So I will go back to the code and start from the beginning. Is everything clear so far? Raise your hands if you have any questions, please. Okay. So any questions, please? Yeah, it's empty. It's empty because we will add more people, and like, you are free to add whomever you like. So it doesn't ship with a default number of people, but it's expected. So what I'm going to do is I'm going to check out the master branch. Okay. Do this if you are on the final branch, so that you see the database is empty and the index file is as little as this. So I want to talk about what these things are doing. Raise your hands if you heard of Express before, the library. Cool. The library is basically what gives Node.js the capability to run a web server in a very nicely and easy to use way. It's really, really easy. Now Node.js also ships with an HTTP server inside, but it's really hard to use, and Express is kind of the default web server in Node.js people use to make backend applications. And hopefully you'll see like we will achieve a lot with only very few lines of code. So we start by requiring Express, as we already did before, by requiring external modules, because it's an external library. And tell me how I would have added Express to my Node.js project if I were setting this up from scratch. Raise your hand and tell me what to type to install Express from scratch. Sorry? Yeah, I can include in package.json, but and then we can do npm install. Yes, that's the way basically. You do npm install Express. This thing adds it to package.json plus downloads all the necessary files, so you can require it here. We did this in lecture 2, I guess, when we installed the red library. Okay, so these are some tedious steps, and I didn't want you to repeat everything, so I set this up, the repository for you, and I'm just going over the index.js. So we required Express, and then we create an application, an HTTP application from this library, and it is as easy as calling that library actually. So I do const express equals require express, and then when I execute that, it gives me an HTTP application already. But currently, like if you don't listen to anything, this does nothing. You cannot interact with this. The sole idea of an HTTP application is that people can interact with it. People can you know, request some URLs, click here and there, and add some records and delete some records. So it needs interaction. Therefore, it needs to listen on a port. It has to have a port. And that's what we're doing. App.listen is a function that you call. You pass it a port number, 3000. It could be anything. In fact, anything between 1024 to 6536. And again, by default, we choose 3000. And then you give it a callback function. Raise your hand and tell me what a callback function is from last week, from asynchronous programming. Please. Yeah, it's a method that gets executed after an event. That's true. And this is an asynchronous operation that deals with the operating system. Basically, we're telling the operating system, hey, I want the ownership of port 3000. So, yeah, you know, just do this for me. And whenever you're ready, just call me back. And it does. That's why it's actually a callback function. So it takes some time on the operating system because if you remember, I told you that ports are unique. So you can only have a single application that's listening on a port. Multiple applications cannot share a port when they're listening on it. Therefore, maybe 3000 is full. Maybe it's already listened by an application. Let me demo that for you. So I run the application here, and it already tells me that the address is in use. It's being used by this terminal here in my IDE, Visual Studio Code. It's already running. So when I stop this, I can run it here. See? Server listening. I go back, try to run it here. I run it with NodeMon, and it says address in use. Okay? I can have it at 5000, and whenever I save it, NodeMon will restart it, and you see that it started listening again. If I change it back to 3000, it will crash again because it's still in use by this other terminal here. I stop this here, I go back, run it again, and it's listening again. So the ports are unique, they have to be unique. Therefore, the operating system has to decide who has the ownership. Therefore, it's an asynchronous operation. And since it's an asynchronous operation, you need a callback function to understand when it's ready. Okay, this is a little bit of a long introduction to listening to ports and then web services. But fortunately, this is all there is to it. Like, there is actually nothing else in listening on a HTTP server. Basically, we now have an HTTP server in JavaScript. People wrote thousands of lines for this before, like 15 years ago. It was thousands of lines to get to this point. And it's, you know, as easy as just calling app.listen 3000 and it works. And it is the beginning of an HTTP server. So another thing that I already included for you is the person service. If you open the file, you'll see that it looks a lot like what we did last week, using async operations and reading from files and parsing them, right? Raise your hands if this is familiar, if this looks familiar. Cool. The other ones have to study more. It's basically all about last week's lecture. So since this is really tedious, if you remember, I told you that some unfortunate people have to deal with this pyramid here, the callback hell, if you remember the term, right? Raise your hands and tell me what a callback hell is. Please, again. Sorry? So it's an infinite loop? No, it's not an infinite loop. Sorry? Yes, exactly. That's the right answer. The answer is it's a series of nested callbacks. So one callback within another callback within another callback within another callback, and you see like a pyramid here or a triangle, and that is a callback hell. That's unfortunate to develop. This looks really confusing. You know, you have a callback here within the promise, and then you have another callback in read file, and there's another extra indentation because this is a function. So this is some nasty code. I didn't want you to write these within the class, so I did that for you. So you're lucky. It's really easy to use this library from now on. But basically, this is what you all did in your homeworks, right? So I have some functionality. If you look at the exported functionality here at the end, this is how you export your library or your functions. We have 4 different functions called find all, find, add, and del or delete. Delete is a reserved keyword in JavaScript. It's actually an operation, so you cannot write delete anywhere. Therefore, we can only type del or delete or whatever, anything that's not delete or remove. But del is kind of the standard. So we are exporting 4 different functions that finds all the records, all the people in my database, that finds a single person in my database, given an ID, that adds a new person to the database, and that deletes a person from the database. It's basically, oh shit. This is why we don't code Java. Because like, what? Why? Right, please skip this version. Anyway, these are pretty much all the operations that you do in a database. You may have some queries. You can say, you know, give me people with ages over 25 or whatever. Actually, it's a very good idea. Maybe we should have done that also. If we have enough time, we can. But yeah, these are basically all the operations that you can do with a database. And if you can see the implementation, for example, how does find work? How does fetching a single record out of that array works? We do find all first. We wait for it, because that's an asynchronous operation. And then we use an array method called find to see if the ID of any person equals the person ID that is passed to this function. So this gives me a person with ID 3, for example, or with ID 2, as I did with the URL. Okay, now this is a reference, find all. So let's see what it does. I control click or command click it to go to the definition. It's still within this file. Find all actually reads from the database, the JSON file. It's as simple as that. It reads from the database. And if you remember, we also added a static method called create to our person class last week. And I'm also making use of that. So we're just building on top of what we learned in the previous lecture. And it says, okay, like I'm resolving with this set of people. I'm reading the file, reading the JSON file, the database file. I'm parsing it as JSON, as objects, and then I'm creating people from that person model. And then I'm resolving my promise. If you remember promises, I'm resolving my promise with that list of people, because that was what I was looking for. So there is nothing new on that side. It's basically what we did last week. Please. This one? Well, yeah, this actually does nothing. So you can remove that. It's just a mistake that I do sometimes, because I'm writing so many async code. It doesn't hurt to add more there. But like it has to be here, because I'm using await here, so you have to have async here. Please.
You said that you had to go through the callback in this one, but would it be possible to write it in this async instead?
Yeah, so the question is, do we really have to go through this callback hell to read a file? if you can find a version, a library that reads from a file with async await, then yes, you can do it. But the function or the functionality that is shipped with Node.js, built into the Node.js, the file system library and read file function, they work with callbacks. So since they work with callbacks, you cannot use async await here. You have to use a callback, and therefore you have to convert it to a promise. So if you find something that works with promises, then you can use the async await keyword. There are actually a lot of file system libraries that just convert everything in the native file system library to promise versions, but they're not the default, so it doesn't really hurt to have it here. And it's a good example of asynchronous programming, because you have to remember that, again, somebody is doing the hard work for you to write this, because there's no default way of avoiding this. Somebody has to write this somewhere, and yeah, it's good to remember that. But then we can use it everywhere we want. For example, how do we add a person to the library? We first get all the people in an array. We use the find all function. We wait for it, and then we call it all people. We get the last person, okay? We get the last person's ID, and we increment the last person's ID in a new person. Why do we do that? Because IDs are machine-generated unique identifiers that have to happen on the server. You cannot expect a user to give you an ID. For example, every comment that you write on Facebook has an internal ID, but obviously you're not generating that ID when you're typing the command. You're just typing the commands, right? So the server assigns an ID for that command. Therefore, you can get a link when you click the time of any command. You can go to a special page that focuses on that command. It's done basically by utilizing this functionality. Facebook attaches IDs to everything, every post, every picture, every comment, and every people. That's why you have to have unique IDs of records in your databases. And you cannot expect it from the customer, the end user, because it's very open to abuse. They can just try to enter an ID that's already existing from one of their friends, whatever, and that doesn't work. So you have to generate it on the server side, and that's what we're doing. When you want to add a person, you are passing in name and age attributes, and we are adding an ID attribute. And this is something called auto increment functionality. We will see this in later sessions as well. What we're doing is we're looking at the final ID in the database, and we just increment it by 1 and assign that new ID to the new incoming person, which is guaranteed to be unique because it's numbers and we're counting from 0 to whatever number. And then this is something we did again in the previous lecture. We create a new person, or there's another alternative here. Help me with this one. What do I type here if I want to create a new person? Yes, new person model in this case. And I pass in the object that has the age and name attributes. Let's delete that for now. And I add that new person to all the people. This is again what you did in your homework, right? And I'm saving them all to the database. And then returning the person that I've created. So how am I saving them all? It's again something we've been doing for the last 2 weeks. We are writing to a file. We are writing an array to a file. Raise your hands if this is familiar. Reading and writing to files. Good. Yeah. So I just wanted to go over the code to explain what it does. And because these are sort of like boring stuff. And in fact, nobody actually writes these anymore because this is really standard and libraries automatically do it for us. And next week we'll talk about one of those. So I just wanted to go over once more how this is actually implemented within those libraries as well. Please, you have a question there. Yeah. Yes, the question is, when you use async await, you also use a promise. Yeah. Yeah. So the only difference is you don't use the then, and therefore you don't need to create a callback, and therefore it's easier to write and read. It's still single indentation, like I say all people await find all, and it really waits until the find all function happens and the file is read from the database, from the operating system, and then it continues the execution with this line, which is just another line below, which is easier to follow because the order of lines follow the order of execution. But it's not the case in callbacks. That's why it's called callback hell, because the order of execution doesn't match the order of lines in the source code, so it's harder to track. It jumps from line 10 to line 15 and then comes back to line 11 and then jumps to line 20 and comes back to line 12. It's really hard to track. That's why async await is a better alternative, because it makes sure the lines are executed in serially, line by line. Okay. Any questions so far? No. Great. We are underutilizing our assistants here. If you have any questions at all, it doesn't have to be related to this. It may be related to your installation or whatever. If you have any questions at all, just raise your hand, and we have several people here to help you. Yeah. Yeah. Okay, here. Mm-hmm. So I'm not sure if I got the question right, but yeah, this is asynchronous operation, and it's a construct built into the language, built into JavaScript. Whenever it sees, oh, I have to await the end of this function, it stops the execution here, goes into this find all function, okay, executes this line, and then read file, and just waits until the file is read from the file system, from the operating system, and then it executes these lines, and then goes back here and executes line 21. But if you are the developer of this add function, you see that line 20 and line 21 execute one after another. So all the other logic is hidden from you, basically. Does it make sense?
No, but it was fake. Like a simple I would just wait all of my
Yes.
Then I go to the next line and find the last idea.
Yes.
That's a normal sequence. That's correct. I have all the data.
Yeah.
That's why I have the last line. But if it's missing, then I'm over here, then the next line.
No, you're not. This is basically the same as the synchronous version. The question is, how does this async thing work? And how does it wait there? And why doesn't it go to the next line already in the execution if it's an asynchronous job? And again, this is a construct built into JavaScript. It basically waits, stops the execution on that line, doesn't go any further until the promise returned by this find all function is resolved. So if you don't resolve it, your execution will just stop there. It will not do anything else. It's exactly like the it's exactly like the synchronous version. It's built like that. It's built to imitate that thing. So in other languages, that's very funny. In other languages, you find that people are trying to imitate asynchronous operations with their synchronous style, because all the other languages are mostly synchronous. And in JavaScript, we are trying to imitate asynchronous synchronous flow of operation, because our syntax is async by nature. We, by nature, operate with callbacks all the time, by events. And it's not easy for everybody. It's not easy to follow the order of execution. That's why they decided to add a new keyword to the language called await, so that it looks like it's synchronous. But on the background, it's still asynchronous. It's still really different. And yeah, maybe we can even show a demo of how that works within an event-driven system like an HTTP server. Because an HTTP server is, in the end, an event-driven system. You have events that are coming from the outer world, like, hey, I'm a user and I want to see this file, see this person details, or see the list of people. That's an event happening for the HTTP server. And therefore, we can actually hang one of these executions here, and we can see that, you know, other people can still request data from our single-threaded server here, because we are doing stuff asynchronously. Okay, there was another question there. You got it? Okay, good. Please. So the question is the resolve function a default function? Yes, whenever you're writing a promise, you have to pass a function to the promise itself as a first argument, and it takes two arguments. One is resolve, the other one is reject. And, well, I mean, you can name this to anything. As long as it's the first argument, you can rename it to anything. But the idea is the first argument gets called with your response, with your result. And yeah, that's, again, the default way. Okay. So let's try how this thing works. I will start with a very simple response, and please follow me from now on and try to write what I'm writing. And I will not deal with the person service. I will just say hello to a response, because if you now go to the web server, come on. Okay, sorry. If you go to localhost 3000, you currently see cannot get slash. Let's start with this. Please run the application and see that this message appears, cannot get slash. And raise your hands if you already did that. Okay, cool. I'm waiting for the others. The address is localhost 3000. And raise your hand if you need help. We have some crazy engineers here who can help you. Yeah, another one here. No, you should see cannot get slash. If you see this site cannot be reached, you should run the application. Oh, you already have hello. Are you on the final stage? Yes. Okay, I thought master branch. Is Vlad here? Vlad? Where? Oh, Can I actually turn off the air conditioner here? This is pretty cold. I'm not turning this off. It's really cold.
Do you want me to switch it to heat or something?
That would be okay, yeah. I'm kind of freezing here. The air conditioning is... Yeah. Thank you. I have a lot. I can do with some less brains and more heat. Anyway, raise your hands if you got so far. Good. The others, please ask for help.
This exercise is more.
Yeah, of course. No, it doesn't, because there's no web page yet. It still can't get the web page. So while we're waiting for the others to catch up, I want to ask you a question. Why do you think it says cannot get slash? Raise your hand and give me an answer. Don't be shy. Please, we have a lot of attendants who never talk. Please. There's nothing in the database, that's true. But it's not the reason for why we're seeing this cannot get slash. Raise your hand and tell me, please. It is. Is it the slash from this URL? And you're right, there's a hidden slash there at the end of 3000. But when I type it, it gets removed because a dangling slash doesn't make much sense. But you're right, the slash is actually that slash at the end, the hidden slash at the end. But still, why does it say cannot get slash? Because we're already running the web server, right? If you don't run this, we see another thing here, site cannot be reached. So we can reach the web server, but we see cannot get slash. Raise your hand and give me an answer. Anybody? Why do we see cannot get slash? Please. Because we don't have the what? The routes defined. Yes. The answer is we don't have the routes defined. And what is a route? A route is something that shows the way to a path. If you remember, I talked about paths, like person/all is a path in a URL. A route says, it's like navigation, maps on your phones. It says, this is the way to the right result. It says, here is the implementation of the path that you're looking for. And when we type the address of the web page, we actually say, give me slash, give me the home page. And it's noted by a slash. But we didn't define an entry point. We didn't define what homepage is. We're just listening to the server. So there is no route for this. This is like, you know, lead me to your master. When you meet a new tribe on an island, you tell them, lead me to your master, lead me to your ruler, to your leader. And they route you to their leaders. But this is like, lead me to your leader and their communal society, and there are no leaders, so there's no route to a leader. So yeah, basically that's the idea. We didn't implement a route that says this is what the home page should look like. We just listen to a server. Therefore, we will add a route for the slash for the home page, and that's what we're going to do now. So again, follow me. I type app dot something to define a route. And that is my next question. What should I type here? Route. That's one answer, but not the correct one. Another answer? Just shout. Get? Yeah, get is the right answer. But the question is why? I should type get here. Okay? That's a function. Sorry? That's a function. And it takes a name. I will give it a URL, a path, that's slash. This denotes again the home page. And then it takes a second function, a handler, a request handler, because we are requesting the home page. A request handler. It takes three parameters: request, response, and something called next, which I will talk about it later, but we won't be using it that much. But it's still good to have it there. And then I say res, which stands for response, res.send. Let's say hello. And let's also put an emoji there. Let's see how it will look like. Res send hello. Okay. So we were discussing why we need get there. Give me some guesses. You don't have to know this. Just tell me why do you think the verb is called get. Exactly. That is the right answer. The answer is I want to get something. I want to get the home page, right? It's the word that we use in English. When I type something on the browser, I tell the browser to get me that thing, get me that URL. When I type Google, I say get me the homepage of Google. That's why this thing is called get. And this is pretty literal on Express. It says when there's a get event, when there's a get action that's happening, when there's a get verb that's happening, just use this function. All right, use this callback function. And it passes you a request that resembles the request of the user. And it passes you a response that you can fill in, that you can operate on. And don't worry about the next. And what we're doing is we are sending the response. So we're doing response.send, which is another function that is given to you by the library. You do response.send and any message that you like. So let's see if our web server is still running. It is. Let's go to the localhost 3000 and refresh, and perfect. We see the response there. So it's as simple as that. Now you go to the address localhost 3000, and however much you refresh, however many times you refresh, you still get the hello message. Does it make sense? We basically built our first web application, backend application. Yay! Now you can really deploy this to any server from Amazon or your own machine even, and your friends can see what you do. We will cover a very, very nice way of deploying applications in the final lecture, lecture 8. And I hope by that time your projects will be ready to publish to the world, so that when you finish that lecture and when you finish the homework of week 8, you can go back to your friends and say, hey, this is the address, please access my web page here. Or my web application here. It's not only a page, it's an application that you can interact with. All right, let's go back. Now, before we take a break, I want to also show you how we make use of our person service. Okay? did you notice that I'm calling it service? Previously, it was just a class, person class. I called that thing person model now, and then I introduced another class, another functionality, and I call it person service. Did you notice this? Raise your hand if you did. Cool. This is a special naming that the industry uses for these kind of functionalities. You have models that represent entities in your databases, objects, classes, like the person that we defined and all of you did in your homeworks. That's a model, because that models the real life. It's like a, I don't know, a plastic model or a wooden model of a car or something. That models a real life in code. That's why it's called a model. So person is a model. And then we have the person service, which serves you persons or people out of the file system, right? That's what it does. The person service serves you people out of the file system. So it's why it's called a service. Basically, it's as simple as that. But it helps to, you know, keep the distinction, keep the differentiation between these two responsibilities. So the person model is, again, this class. This is something that we wrote last week. It has a name and age. I also put in some ID, and I give it a default age of 0. Because when you create a new person, how old are they? When you create a new person, when you have a baby, how old is that baby? 0, right? So the default age is 0. If you don't give it an age, when you create a person, the default age is 0. This is how you denote the kind of the default stuff, or you could also type it here on the top, age equals 0. And yeah. And maybe even for the name, if you create a new baby, maybe it doesn't have a name yet, right? The name is empty string. So you can actually do this as well. The default parameter, the default value for name is empty string, the default value for age is 0. Does it make sense? Raise your hands if it makes sense. Perfect. And then we have a static function called create that basically does new person, right? Okay, this is what person model is, and this is person service that is responsible for making use of this person model and serving it out of the file system. And its responsibilities end there. Basically, it gives you functions to find all the people, find a given person with an ID, add a person to the database, and delete a person from the database. Okay, let's make use of it here. How do I do that? How do I make use of another module in this module? Raise your hand and give me the answer. You all did this in the homeworks. Don't be shy. Everybody knows this. How do I make use of another module here? Please? What? We require it. That's right. So, can you help me to type it? What do I type here? Perfect. That's right. Const person service equals require services person service. Actually, the ID is already auto-completing it for me. And this is what I do. All right? And let's say I want to display the list of the people in my database when I request the home page. What do I do? Come on, tell me. Please? Sorry? Yes, we have to send something out of the person service, that's right. But what out of the person service? All, find all, yes, exactly. That is that functionality. So if you actually start typing person service and type a dot, you see the first results are the functions that are available to you from the person service. And we have the find all here, and that's what I want actually. Find all. I want to send this, but do you think this would work if I do it like this? Let's try. I save this, and yeah, maybe even I can bring this to bring this window to here. Yeah. I refresh it, and I get an empty object. Well, my database is empty, right? Maybe that's why. Database JSON. Let's cheat here and put some manual results. You don't have to do this. You don't have to follow this. But let me add here a dummy result and save it. Let's refresh this. I'm refreshing the web page and I don't see anything. Why do you think that's the case? Sorry? I didn't send it to the browser. I did. I'm using rest.send to send it to the browser. Do I have to require the database? No. The person service already takes care of that. It already requires the database for me, and find all actually fetches that information. Let's see what find all is doing. What do you think it's doing? Sorry? Please, anybody? Sorry? What is this find all doing? Yeah, it reads from the file, well, checks if there's any error, and if there are any errors, it rejects the promise, but there won't be any errors, and it creates an array of people, and it resolves that. This is the key question. This is a promise. This will happen in the future, but the way I'm using it right now is synchronous. How do I know that it's synchronous? Because I didn't type async, await, or then. So I'm trying to use it synchronously, and this won't work. This has to be an asynchronous operation. So how do I do that? I first write await here, because this is an operation that you have to wait for. It will read from the file system, right? And also you have to add async here, because you now have await there. All right? Save this, refresh it, and you have the result. Does it work? Raise your hands if you can get it to work. 1, 2, perfect. We wanted to find all records in the database, and we sent it from the server to the client's browser for handling the GET request. These are all terms that you have to make familiar with, that you will hear forevermore now that you know how to do backend applications. We did a request handler here. This function is called a request handler for the GET request here, and we sent back the list of all the people that we have. Currently we have 1 person, and that's what we have. If we had more people, we would see more on this side, and you see the URL is localhost 3000. All right, let's build a web page, because this is not a web page. This is just some text that is really ugly. Okay, and in fact, I added something called an index.html. Please open that. Raise your hands if you didn't see an HTML file before, if this is the first time you're seeing an HTML file. And that's perfectly okay. All right, 1. Okay, cool. This is basically the definition of a web page. HTML stands for Hypertext Markup Language, and the keyword is hyper. So if you look here, this is only text. This is only some letters, some characters. And a web page is much more than text, right? When we have, GitHub, you see some text, but then you see a lot of other stuff here, which are not text. We call these hypertext, which is something beyond text. That's why, HTML is a language, a markup language, to mark up these special features, like to make these stuff bold, or to make stuff underlined when they are hovered. These are hyper additions to text, actually. So that's what HTML is for. And this file is basically, it lists properties of a web page. It has a title that is visible. Well, it's not visible here because we didn't build it yet. But for example, this is the title for GitHub. And it has some style definitions to change the font and some scripts. If you remember, we wrote some code in our browsers on the first lecture. This is basically a place that we can write and run those codes. This is called a tag. This is a script tag, and script is basically a piece of code. And you can write anything here. So I want to demo that as well. And then we have a body. H1 stands for heading 1. So this is the biggest title on the web page, and we say hello. So this is the definition of a simple web page, and I want to make use of this. My home page should basically serve this file, save this HTML file, so that it looks nice. And let's see how we can achieve that. Please. This one or the HTML? Yeah.
What's the difference between the body, the video, and
this one. So this is a style definition. This defines how the body should look like, and I'm defining the fonts to be used in the body. It's an implementation detail because the default is very ugly. So I put it here so that it looks a little bit nicer. But yeah, this defines what the web page should look like. And the body here is actually the implementation. It says what the body is. And the body currently says hello. And we'll see this in action. But this is an HTML file that I want to serve to my customers when they navigate to my homepage. Okay?
The upper is like a schema.
Yeah. Yeah. The one here is like a schema or template, let's say. All right. So I want to do it here. Let's comment out this piece of code. I use a shortcut, command / or control / to comment it out. And if you remember, I told you that I want to send this file to the users when they request the home page, right? And how I'm going to do that is I start by res, which is the response object, and I use send file, because this time I will be sending actually a file. Does it make sense? Yeah. It's a function that takes a path, so I give it index.html because the file is called index.html. Let's see if it works. Let's remove the async here. Something that I forgot. Okay, I got an error. It says path must be absolute or specify root to res send file. Yeah, so the path here, it doesn't like this. This is called a relative path. The dot actually refers to the current directory that I'm in, and I say, you know, take the index.html file that is in the current directory, but this says, you know, that's a little bit ambiguous. It's a bit vague because I can run the script from any directory. Like the current directory doesn't really make a lot of sense to start with because it could be any other directory as well. So it says give me an absolute path so that I exactly know where that file is in my file system. And you could do, if you're on Windows, you could do, you know, C users something something something, which is not that useful because this only works on your computer and in a single folder. So I wouldn't want to write this, or on Mac this would be the other way around, like this. Well, this doesn't make sense. I need something, an identifier, which will help me with getting the directory this file is in. Because if you look at it, index.js is side by side with index.html. Wherever I put these files, they will be side by side. So I need a reference to the current folder, to the folder that I'm having this index.js file. There is a special syntax for it. It's called __ dir name. Gives you the directory for the current file. So I just type this and refresh it here, and I see the hello. See, it's a nice font. If I remove the font declaration here, it will be really ugly. It will be Times New Roman, which I hate as a font. This is not good. So I have the style there. But okay, what I did was I did res send file. Please. So if I'm correct, you asked about the dir name. Yeah. The dir name is something, a variable that's automatically injected by Node, and it gives you the current directory of the file that is in question. So we have the index.js file. The dir name gives you the directory of that index.js file, wherever it is on the file system. Exactly. It gives you the root of the index.js folder, and then I use index.html. Yes. Actually, if you look at person service, we already have it here. We have dir name, and we have ... which says go up one level, and then access the database. Why do we do that? Because the person service is actually inside a folder, and the dir name gives you the services folder. So we have to go up one level to access our project folder, and that is where the database is. But again, this is an implementation detail that you don't really have to worry about. Okay, raise your hands if you saw the hello message in your browser. Good. Then I'm going on with something else. So this is a static file that I'm sending out to users, right? Now people see hello, but there is a problem because this file is set in stone. It's a file that I host on my hard disk that doesn't really change with anything. The only way to change it is to change the contents of the index.html file, upload it again to the server, or commit it to Git, and restart the application, etc. That doesn't really help because I need a dynamic application. I need to show data within that file. I need to show the list of people. If you remember our final example, we want the list of people displayed there. We want the details of people to display there. So it has to be dynamic. I have to be able to inject new content into the file that I'm sending. Does it make sense? So the idea is this index.html file is static and I cannot use this. I need another mechanism. This mechanism is called the view layer. Why is it called view? This is kind of bad naming, but it worked for the industry for like 40 years, 50 years. It's called the view because it's a perspective into your backend system. If you remember the list of people that we have, it's a view, a look into your database. Your database has those people, and the web page that you see those people in is a nicely designed version that presents you that data. It's a view. It could be any other view. It's like a political view, right? You could be a leftist, you could be a rightist. If you're a rightist, we have problems. But that's what it is. It's called a view, basically. The same as like the world view or any view that you imagine. That's why it's called a view. It's an understanding, a perspective into your data. So we have to have a view mechanism which we can inject some properties, some attributes, some objects like the persons array, and that view mechanism will automatically generate a new HTML file on the fly as a response to our request and send it to the user. So it's a dynamic way of creating HTML files on the go because static HTML files don't work for us. We need a mechanism to create an HTML file that will be dynamically generated with the information that I pass to that. Does it make sense? Please. Exactly. Exactly. Yes. It's a visual representation of our data, basically. So I already got you covered there as well. On the right, you also have a directory, bless you, called views. And in it, we have two different files. One is called layout.pug, the other is called index.pug. Let's open layout.pug. It's a pug file, it's not an HTML file. And pug is a special syntax that is a lot simpler to type with respect to HTML because you don't have ugly, bigger, or greater than or smaller than signs. And it's basically, it looks a lot simpler. Let's put them side by side. Let's put index.html here. Okay. I will make this a little bit smaller, just for now, so that you can see the difference. They are kind of doing the same thing until line 12. So you can write the thing on the right, or you can write the thing on the left. And I prefer to write the thing on the left because it's a lot simpler. You see there's a style tag that's opening here, and this is a closing style tag. But for example, here I don't have it. I just write style and it works. Or there's a script tag that's opening here, and there's a script tag that's closing here on the right. But on the left, I don't have it. It's just script. So this is a lot simpler to write. And this is something that I will use as a template, as a layout. This piece of code will be in every HTML that I produce. Okay? Because I want every HTML on my web application to have a title that reads WTM BJS4. And if you go to the web page again, we have this title here. Women Techmakers Berlin JavaScript -4 test. It was the title here. All right. And in order to show you the difference, I have a different title here. But every web page, whether it's a people listing or people details web page, it should have a title. And don't worry about the script right now. It's including the Axios library that I demoed earlier. But basically it's the same thing. And I have console log hello there. Let's see it in the console. I open the developer tools, the console, and it's there. You see the message here, hello there. So you can also type, not there, but here you can also type any other thing, 3 + 5, and when you refresh it, you'll see the result there. So this is where you can put all your code and you can run it. if you like, on the front end. Okay. Now that we covered the basics, there's one more thing. The index pug. Now, if you remember, I told you that this thing will be dynamic, right? This thing actually will host content of my people, of person details. So index, the homepage, which we call it the index, like a phone book, there's an index, right? The homepage is also another content that I want to display. It also has to be dynamically included within this final HTML that I'm generating. If you see previously, I had the index HTML and hello was embedded in it. But in fact, hello is something that I want to show only on the homepage. The other pages will display the list of people. Therefore, hello is also a content for me. That's a keyword. And that's what I'm doing here. In the index.pug file, you see that this is actually something that extends layout. Layout is the one that we defined here. And it defines a content block, and it defines the, well, ingredients, the contents of that block. It says hello. And if you look carefully here, you see there's a block definition in the layout where we define, hey, I'm a layout and I need some content. And this is where it should go. Any content that you produce in your app should be here, should come after this line. So what our view layer, view system, view engine will do is it will look for this block content definition. It will fetch the index pug file here and see, oh, hey, here is the definition of the content. And then put this hello in there. And effectively, what you'll get is the same as this HTML file. Does it make sense? Are you a little bit lost? It's okay if you are. Raise your hands if you have any questions. It's all right, and I will answer them. This thing is very fundamental. Please. Yeah. How does it happen in the browser, right? Yes. So we didn't cover that part yet. But the question is, how does it work with the browser? Because an index HTML file is something that a browser can understand, but the pug files are different. How does it work? And the answer is basically that what we're covering now, what we'll cover now. We will tell our Express application to generate these HTMLs on the fly by using these views. And it will create something like an index HTML file on the background. And yeah, let's actually do that. It's the right time to do that. So one thing is a package that we automatically installed. It's called pug. Now Node.js or Express doesn't understand pug by default. You have to install this library to make it work. When you did an npm install, it was automatically installed for you because it was in package.json. But if you didn't have it, you'd write npm install pug, right, to install that library. So it's already automatically available to us. And yeah, all we do is here app.set, this is a setting. And there are some examples here. View engine, okay? And the second parameter are at pug. And I declare that as a view engine, use pug. So I will be passing some views to you. When you want to render them, make sure you use the pug engine. And as you might imagine, there are hundreds of other different view engines that you can use within your Express application, but pug is the easiest and I hope also kind of the standard in the industry. So that's why we are doing it with pug. All right, beforehand we were defining the exact file to send, right? But right now we will generate it on the fly. Actually, since this will be a visualization of our database, we will render a visual. We will render the HTML page. If you heard that term before, this is where it comes from. We have some data, and we have some template, we have some layouts. We want to combine these, and that action, that operation is called rendering. So we will render a view with some data. Currently, there are no data that we're passing, but that's an example that we will do. So how do we do that? Let's comment it out. How do you think we do that? How do you render a view? What do you think? Yeah, it's as simple as that. We say res.render. Basically, there's nothing else that goes here. So if you type a parentheses, you see the documentation. Render view with the given options and optional callback function. Okay. So the first parameter actually is the view. The second parameter are the options or the data that you can pass to the view. And I want to give it the index because that's what I want to show. The index view is what I want to show, which extends the layout view. All right. So the layout view will be automatically included. It's like I copy this, go back to index pug, and it's like I paste this here. This is what extends does, so that I don't have to paste it in every pug file. All right, so let's save this and go back and hope that it works. Sorry? Yeah. The question is, I have layout instead of index, and layout comes automatically because index extends layout. Layout is not something that I can want to see. Like, I cannot expect to see layout. Layout is just a general meta thing, and because I actually want to get the index file. I actually want to get the home page, right? I could also name it home page, wouldn't matter. And then the home page says, okay, but I have a friend with me, and these are the most horrible people in parties. You invite somebody and they say, I have another friend. Can that person also come? And you have to say yes. It's basically like that. You actually want to see the index, but index says, yeah, but I have the layout, so we will render together, and you get the result. So actually, if you look at the source code of this, it's generated. Check the title. We have the correct title, so we are running it. And this is the HTML that gets generated as a result of that pug file. So I hope this answers your question. Express, when confronted with this task of rendering the index view, takes the index view, index pug file, parses it, understands, actually pug does that as the view engine, parses it, understands it, sees that there's a need for the layout, takes it, parses it, understands it, and produces this final HTML file and sends it out to the world, to the user basically. So that when you hit the URL here, you get this HTML file. So currently it's exactly the same as the other index HTML file that we created. There is nothing dynamic here. But this is the foundation of something dynamic. And now we will finally give a path to our people's listing. The next thing is actually I will list the people here. Okay, any questions? Please. Yes, the question is, would you use Pod if you use a front-end framework like React? Yeah, or would you replace Pod with React the same way you replace an HTML file with Pod? The answer is yes and no. if you are doing server-side rendering in React, you will use that. You will use a special view engine for that. But if you're not using a server-side rendering tool, which most people don't, which is just a front-end app, then you use Pug still with the layout. And then in the layout you have, if you see the script definition there, that is where you include your actual React application or any other framework on the front end. That's kind of the rough answer. Any other questions? All right. Is everything clear so far? Raise your hands if you got Pug working. Like if you could follow me in this part. Perfect. Perfect. All right. Now, I have a person in my database, right? It's here. I will demo this once more. I could comment out this rendering and I could comment in this await person service find all, save it, go back to the web page, refresh it, and it would crash. Why did it crash? Oh, missing. Oh, who was that? Yes, perfect. That's right. I don't have async here. Yes, refresh and you get the result, right? So I'm going back. I remove the async, comment out the person source find all, comment in the rest render index, and I will see the hello message. So this is my home page. I want this to stay like this. I will create a new route to fetch all the people. Is there a question there? Okay. So I will create a new route and a new view to put the list of people because it's different than my home page. I don't want to show anything on my home page. Let's do that. How do I create a new route? What do I need to type to create a new route? Raise your hand and give me an answer. Sorry? Yeah, app.get. That's right. Why is it get? Anyone? It's a root. But why get and nothing else? Yes, because we want to fetch the web page. We want to fetch the list of people. We want to get the list of people. Therefore, I'm using get. Okay. In our final example, it's something called /person/all to get the list of all users. Okay. Basically, I'm doing the same thing. Request, response, and next. That's a function. Let's copy this from here. Await person service find all. Const people equals await person service dot find all. And since I'm doing this, I should also add async here. Otherwise, it won't work. So I got the list of people, and I need to render a view. I want to call that view person. So I say res.render person, which doesn't exist yet. I will create it shortly. And I want to pass in an object like this. This is my way of telling the view engine to use this object in the template. I say, hey, this is the list that I want to render. Take this is an array. Take it and do whatever you want with it. And let's create that view. I go to the views folder, create this create new file button, and type person.pug. Okay? And what is the first thing that I'm going to write here? Yes, please, louder. Extends layout. Why? Yeah, because we need to import the layout to this file. Because I don't want to repeat what I wrote there. HTML, head, title, and these definitions. I don't want to do them again. So I type extends layout. Okay? And what is the second thing that I'm going to write here? Blog? Exactly, blog content. Why do I need to type this? Anybody? Don't be shy, you all know it. Yeah, please. Yeah, this is the dynamic part of the layout. The layout says, whoever you are, just define a content block and put whatever you put there, and I will show it. So let's do like add a header and say the list of all the people in the world. All right, and let's save it. And let's go to the browser. I will again put this side by side with the editor so that you hopefully see that. Okay. Yeah. All right. So this is the URL that I have for the homepage, localhost 3000. I type person/all, and some things crash. All right. Person is not defined. Where is the bug in my code? The bug is I have something called people. I don't have defined person yet. So this should be people, and maybe this should also be called people. And if you see here that I'm repeating this thing, right? I'm typing people, colon people. Whatever I type here, if I change the name, I will change this key as well, the property name as well. So they thought, the smart people who designed the next version of JavaScript, they thought, well, this is redundant. We don't need to write it this way. So they decided that this would also do the same thing. So this thing, people, colon, people, is equal to just typing people. And yeah. Oh, on the right, we already have the heading. The list of all the people in the world. Let's change it. The list of some people in the world. And let's refresh it. I see the heading update. So I have the layout, right? And I passed in this people object here. Let's make use of it in our template, in our person template. Maybe let's use the number of people that I have in this heading so that it updates with each person that I add. So that it says, you know, the list of 2 people in the world, the list of 3 people in the world, and it should be dynamic. The first thing that I have, if I have an array, is its size, its length, right? So I can edit here. So how I do that is with a special syntax. Please. All right, it's a bit fast. All right, I can trace back the steps and take it a little bit slower. But where's the point that I lost you? All right. Okay. So the idea is I want to show how many people I have in my database. I want to show I have 3 people, 4 people, whatever. I currently have 1. So it should be dynamic. How do I do that? I will replace this sum with the number of people. So it should be something like people.length, right? In the end, this is what I'm going to type. But if you notice, there is no syntax highlighting, like the color of this thing didn't change, which indicates that this is still text. When I save this as a file and when I refresh the HTML page, you'll see that it says people.length. So there should be another way of showing the actual value of this thing. And basically it's done by this special syntax here. Hash, curly brackets, the value that you want to type, like people.length, and close curly brackets. Let's save it and let's refresh it. And you'll see that it updates with the number of people that we have. the list of 1 people in the world, because currently we have only 1 person. Please. The index.js, the index.js is basically getting the list of all people and passes it to the view. This is a very common pattern that everybody will do. Everybody does in the industry. If you're doing Express and HTTP applications, web applications, all you do is you get a list of items from somewhere, from a database, and you pass it onto a view layer to render it. That is all we're doing. Like your Facebook feed is actually an array of feed items. In each feed item, there's actually an array of comments. Basically the same thing. They are doing the same thing. They are fetching that list from a database and then passing it to a view layer to render the final HTML. Raise your hands if you followed me so far with the code.
Even if it is fast,
Cool. Let's spend 5 minutes to get up to this point. And raise your hand to ask for an instructor. They will come and help you. Sorry? Wait. So you want to make the code bigger? And then get the person plugged here? Does this make sense?
need any help. It's working. Oh, because you have to update the URL. It's like versus threshold. Small person. Small person. Oh, you have a person not defined error because there's people. No, that's people. No. Yes. Sorry, that was a mistake. If you have not one, but yeah. No problem. Anyone else needing help? Anyone needs help? Yes, back there. Anyone needs help?
Anyone else who needs help? Raise your hand. Do you still need help? Any money?
I had no idea. You have homework. Are you doing homework? What was it about? Nothing.
Okay, I'm going on with code.
I haven't finished. Oh. If you have any questions.
All right. Raise your hands if you followed me so far. Good. The other ones, please. Oh, careful. Oh. The other ones, please raise your hands and ask for help, and we still have some instructors to help for you. And yeah, I will go on with expanding this view, okay? If you have it here, it shows you the list of the number of people, but not the list of people. So it should show us in a nice way the list of people that we have, like their names and their ages and their IDs. It would be nice if we could see them, right? So let's do that. So, how do you think we will implement it here in the pug file? The question is, how do you think we will show the list of people here in the pug file? For example, I can do a paragraph, P, and this is called interpolation. I'm interpolating an actual value in the template. I can say people 0 dot name, right? And save it, and go back and refresh, and you get the name. Let's add a second person to the database, again by hand. Again, you don't have to do this, because we'll automatically do it in the future. But I'm adding a second person. Let's go back and refresh it. The number updated, the list of 2 people in the world. That makes sense. But of course, I don't see the name here. Right? What can I do? People 1 dot name here. Okay? I basically had a new person in my database, and in the template, I added a new paragraph to get the details of the second person. All right? When I refresh it, I get the name of the second person. Does this look good to you? Yeah, that is the question. What happens if you have an arbitrary number of people, like 100, 200? This doesn't really scale. Like, do you have to actually know the number of people that you have? Like, can you do something easier, something smaller? Like you write 2 lines of code and it does it for you automatically for however many number of people that you have. Yeah, like a loop, right? Like a for each loop, please. Can we use what? For each. That's actually a very good question. Let's see if we can use the for each function here. For example, or let's use something very similar to for each, like map. If you remember, map was also a very similar function to for each that we used last week. We can use map, people map, p, this is a function, get the person and return me the person's name, person name. Let's see what this does and refresh it and see, well, now we have a list of names. So I could use something like this, people.map, to give me the name of each person. Okay? And print it here. Now this kind of works. I wanted to define a paragraph for each person, but I couldn't do that. If you look into the output HTML here, it's still a single paragraph that is joined by a comma. So this is not exactly what I want. I want to list them in different paragraphs. A paragraph for each person. Now this is again a keyword. Now you have to bear with me a second because I very funnily don't remember the whole syntax, but it should look something like this. For each person in people, just type person name. If this doesn't work, I will just look it up on the documentation, but it looks like it works. It's for each person and people. No, it didn't. What if I do that? Oh, it worked. All right, I didn't need to go into documentation. It's each person and people. It's for each person and people. Do the following. Put a paragraph and put their names. Okay? And you can also say, write their ages in bold. Now, the way we mark up bold text is by using something called strong, using a tag called strong, because it's a strong emphasis on that word or on that phrase. So what I do is strong person.age. Okay, I save this. Let's see what happens. I refresh it, and cool, I get the ages. This is fine. We are already getting somewhere, right? We are displaying dynamic data. This is good. Now let's actually implement adding something to the database. All right? And then I can refresh this as much as I want to see the new people there. I know this looks ugly, but just don't worry about that. Like, there should be a space in between and etc. But let's actually add a functionality to add people to the database. How do we do that? So, is it the same action? Will we use get? Or do you think we should use something else? Yeah, some of you already obviously know the answer. It's called post. We should use another action here. And that action is named post. Let's first start with the question of why do we need another action? Why is it different than get? Raise your hand and answer me. Why do we need to use another action? Why cannot we use get? Yeah, that is actually the right answer. We are writing something. We are saying, hey, like, I have a new person that I want to put it into the database. Please take it. And, you know, you would maybe insert it in the database, and hopefully I would get a new person in the database. We are actually making a demand. And unfortunately, this is, again, some very bad naming in computer science. The reason they call it post, because they thought it was like sending a post mail, like a mail by post. You're making a request. Let's say you're telling the ARD to deduce 17 euros every month from your account. So you give them consent to withdraw money from your bank account, and you do that by mail. There's no other way. You have to write a mail and post it via the post office to ARD so that they get money from your account. So this is the analogy that they're using. They're posting a new person to the database. That's why the action is called post, and it's different than get. All right. So I will use the person as a URL. Whenever you post a new person to the person URL, this thing should add it to the database. What is the second thing that I'm writing? The second parameter for this thing? Please? Sorry? Callback. Yes, we need to write a callback function. Now, by definition, we all know that it will be asynchronous, so I can write async here. Request, response, and the infamous next. And let's open the person service here on the side to see the definition of the add. Okay? So it expects a person. It's an async function. It expects a person and saves it to the database and returns that person. All right? So how do I make use of this? there should be a mechanism for me to get the details of the person from the end user, right? From the person in the browser. The person in the browser should indicate the details of the person, the request, the details of the request, the new person that they want to add to the database. This should be embedded in the request that I'm receiving. Let's say, you know, you have this ARD again, you're giving them your IBAN. You have to indicate your IBAN in the letter itself, in the post itself, so that the people over there can open it, take out the body of the letter, and then find the IBAN there and, you know, withdraw money happily from your account. So this is basically the same thing that happens here. There is something called, or there should be something called rec.body. Okay? Now this thing should hold the details of a person. Let's start with just logging this. Console log request.body. You don't have to follow this. I'll be quick here. So whenever I'm making a post to this endpoint, I will get a log of the body. Let's see how it works. So if you remember, I said there is a library here called Axios. It's actually here. Axios actually, or Axios, I don't know how it's pronounced. Axios helps you to communicate with the backend. And it helps you to do GET requests, it helps you to do POST requests. Let's start with the simplest one, the GET request, axios.get / okay, and then, since this is a promise, and then let's console log it. And that's what you get, the data here. Or in another terms, then we get a response, console log response.data. Again, you don't have to type these, just watch it. So I'm getting the home page, it gives me a response, and I'm logging the data of the response. All right? When I press enter, I get the home page. So I can do it again with person all. Here, /person /all, and logging the data again. And you see I have the list of 2 people in the world, and I have the list, basically this thing here. So this works with GET requests. Let's see how it works with POST requests. So I do axios.post, okay, /person. Let's first try this one. Then response console log response.data. All right. So you see something popped up here, and it says undefined. Whenever I'm making a POST request, okay, there is an undefined here in the logs. Now, why is that happening? Let me close this thing and open the index.js. Why does it happen? Is simply undefined. There is no body. I'm not sending anything with the body. I'm just sending an empty mail, if you will, through the post. I'm just posting, almost like trolling the service there. So let's pass some data to this. Let's pass a body. I use it with the second parameter. Let's say message hello. Okay, and I ran it. Oh, I don't see anything. What's going on? Okay, I'm running it again. Okay, I see undefined. I see undefined whenever I run this. And notice here, do I get any response there? previously I logged the result, right? I don't get a response here. Why is that? Because I'm not returning anything here. I can do rest.send. I got it. And now I will basically receive a response. I get it, I get it, I get it, I get it. This thing will work. All right, but still the body is undefined. This shows me one thing. Express doesn't understand the body of the request. Now, this is very silly. I don't know why this is not built in, but this is a plugin that we have to use to make Express understand that there's a body that people are trying to send us a message. And again, if you go to package.json, oh, actually, I forgot that. That's weird. All right, let's edit then. npm install body parser, body dash parser. Let's do it all together and see if the Wi-Fi will hold. Oh, it did. npm install body parser. So this is a library that you have to use to, unfortunately, parse the body that's coming from the requests. Okay, I'll go back to index.js and now make use of this new library that I have. Okay? How do I make use of a new library that I have, that I just installed? Tell me. Raise your hand and tell me. How do I make use of a new library that I just installed? We've done this a couple of times today. Anybody? Yes, finally. Why? Like, it's the same thing, right? I say const body parser equals require body parser. That's all. I just require the body parser library. And now I have to tell Express to use this new library that I have to parse the bodies of each request as JSON, because they are sending JSON to me. This is again some keyword. Again, I'm trying to tell Express to use this body parser. I do that by typing app.use, and I pass in body parser. And since I want this to basically be a JSON parser, I also have to indicate that. So body parser.json is what I'm giving to Express so that it can hopefully parse the bodies of the requests. Let's restart the service. Let's send the post request again. And on the left, you should see a message, hello. So we made Express understand the messages that we're sending from the front end. Raise your hands if you got it. Cool. Yeah. Please try to catch up. Now you just saw how we actually communicate from the front end to the back end. So any application that you use, again, like Facebook, whenever you hit that comment button under each feed item, it does a post request and it sends the details of the comment exactly as we're doing right now. Which means now you know how to send data from the front end. You can actually build web applications. Again, this is all the fundamentals of building web applications. I would love to tell you that there are actually a ton of other stuff here that you have to learn for years, but unfortunately this is all there is. everything from now on builds on top of this thing. You make a request from the front end, from the browser to the back end, and you do something on the back end and send the response back, and that is all there is to it. Now let's turn this into a real person thing. Who has followed me so far? All right. Let's actually make this useful. So, yeah, what I want here is I want to create a new person, right? Let's open the person service again and look at the add functionality. It basically expects an object and creates a person from that object and saves it to the database. All right. So all I do is I call person service dot add, and what do I pass in? What do I pass into the person service to add to the database? A name, yes. An age, yes. Or as a group, well, I want to add a single person. I can't pass in people. A person object, that's true. And there's a step further. What? A person, yes. But do I already have that person object? Yes, where? In the database, but this is something new that I want to add a new record to the database. So I'm expecting this from the user. Let's maybe first demo that. What should happen is on the front end, when I'm posting to person, I will give it a name and says Juan, and I would give it an age. Okay? And when I run this code, I expect it to be added to the database. Let me refresh it. It didn't add to the database. All right, I run it again. I log it here, name and age, but it's not added to the database yet. Why? Because I didn't call person service add yet. All right. Now the question, how can I add this to the database? If you see it here, I'm logging it here, right? How can I add this to the database? What is this thing that I'm logging here? What is the... It's the body that was in the request, right? It's as simple as that. Here, request.body. And it already includes the name and the age. Yeah, body parser does... No, body parser already did that for us. No, I will just pass in rec.body. This is all that you have to write. And it would be nice if you awaited it, of course, because this is an asynchronous operation, right? And then, if you go to the definition of the add function, it also returns you the new person that it created, right? It creates a new person here, and it returns that person. Okay? So I can actually send this back to the user to indicate that, hey, I got your record, and here's that record. Because I told it that I got it, but I actually didn't in the previous case. So let's say this is person, const person equals await person service add, and res send what? What am I going to type here? It's very simple. Just shout it out loudly. Raise your hand. What am I going to type here in between the parentheses in res send? I want the person that I've created to send it back to the user. What do I type here? Person, of course. Come on. It's really simple. I'm sending the person back. Okay, I saved it. Let's make sure there are no Juans in the database. And let's run this code on the side. And look what I got. I got ID 3, which is already an indication that it's already added to the database as a third person. And the details, and when I refresh it, I see it on the web page. Why? Because it's already dynamic. It already pulled in the list of people, and you see like it has now 3 people. Does it make sense? Raise your hands if you think this turned out to be easier than you thought. Okay, 2 people, 3 people, 4, 5. The biggest complaint that I have with newbies or junior people is that they think this is really hard. But unfortunately, it's not. Or maybe fortunately, it's not hard. All we do is 2 lines. We just wrote 2 lines. We said, hey, person service.add, okay, and it would be really nice if you could give back that person that you created so that I can send it to the client, to the browser. That's all I did. And let's add another person. Let's add Tiago. I think he's 28. Oh, I lost the name. 28. ID 4. I added 28, right? No. 26?
No.
Okay, 48. Okay, so well, this is how I add people to the database. All right. Now, we don't have a lot of time, and I could implement the deletion, how to delete people. But maybe I will do that. But just watch me, okay? I will be really quick to type it out for you. So, the action that you use when you want to delete a person is delete. This is good naming. When you want to delete a person, it's good naming. So, person slash, let's say 3, like I want to be able to delete the 3rd person. Async request response next. And let's see the delete function here. It doesn't return anything, but it removes that person with the ID. Okay, it takes in an ID. So how do I use that? Await person service dot tell, and it expects an ID, and I will give it 3. Okay, and then say okay. Let's save it. We have the number of people here. On this side, it's axios.delete person 3. And then again, console log. Oh. Yeah. So, I deleted the 3rd person. Who is the 3rd person here? Is it Juan or Tiago? Juan. So, this is how it works, but it's not dynamic. What happens if I want to delete the 4th person? Does it work? Like person slash 4. No, I actually received an error. It says request failed with status code 404. Raise your hands if you know or if you have ever seen 404 before. Yeah, everybody, right? Because they're using web pages. 404 is the status code for the missing thing. It says, well, there's nothing like that because we didn't define a root for person 4. You cannot delete person 4 yet. So we could also do it with a body, but it's not the way to do it, and I will explain it next week. But there's something called parameters, request parameters, and that's something that we discussed in the previous hour. So you actually define dynamically the ID of the person that you want to receive, and you put a column there. Okay? Now, how do you pass this on? This thing is available as a, tell me, I used the word. Person ID will be available to me as a parameter. That's right. Rec.params, because writing out parameters is very long. Rec.params, and what do you think I should type here? Yes. That's it. Person ID. I save this. Now, who is the person with ID 4? Huh? Who is the person with ID 4 in this list? Tiago. Oh, yeah, Tiago. So let's refresh it. He's gone. ID 1, it's me. I run it. I refresh the list. I'm gone. Okay? ID 2, it's Miri. I refresh it, and Miri is also gone. Which brings us to the end of the discussion. We should be gone. The time is over. Yeah, well, basically this is all that I want to explain today. I actually wanted to go one step further and create the file structure on the final branch, but I will do it next week, very briefly. So please check out the final branch. The difference there is, what you should look for is that there is a folder called routes, okay? And in that folder, we have a person route, and that is where I define all the functions. Like beforehand, I define all of them in index.js, but you can imagine that it's really hard to maintain when they're all in a single file because you will have hundreds of them. Think about Facebook again. So you have specific files for each type of request. Let's say I have one class, person. If you have more classes in your homeworks, you will do more of these routes. And you can investigate how it works, but basically it's a file that includes all the methods, delete, post, get all, for the homepage for the people, okay? And in the index, it's now very simple. What you do is, the homepage obviously should be in the index. It doesn't belong to the person. It's the homepage of your web page, web application. And you see here, these two lines are magical, almost. You're requiring the person root definitions, and again, you're using them. You're using them for the person path, all right? So anything that goes under person actually hits that root over there. It's the root that is defined on this file. Okay? This is the person.js on the left, and on the right you see the index.js. When I say use, the requests actually get here. And notice here how I don't have to write person anymore. Like this is the all. It was previously /person/all, right? But I don't have to write it because I already wrote it here once. Now this is how you build an application that can grow to hundreds of different routes by utilizing this functionality. I will talk a little bit more about this next week, so don't worry if you panic, it's okay. We'll cover this. But for the homework, if you can imagine, the homework will be, again, build your application, your current application in week 3 in such a way that we can interact over the browser, basically by utilizing these things. Make it a service, or if you have multiple classes, make multiple services, okay? List them on the front end, the items in your database, and the details of the items in your database. And hopefully you can do some interactions with them, because you also have a lot of methods that do interactions with them. Hopefully you can also implement those. And if you have any questions, we'll meet on Slack. Let's be active. Next week we will use a real database, which is the final step of a web application. We will use a real database called MongoDB, and I want you to install MongoDB on your machines before you come to the class, because it's huge. I will also write this on Slack. And basically, instead of a file, we will use a real database to save our records, and that's amazing. That will be the end of everything. Obviously, we'll have 2 more sessions or 3 more sessions after that to cover other topics, but that is the fundamental. We will write to a real database, and yeah, that is the way to do a web application. So if you remember, we'll have graduation at the end, and you are supposed to come up with an application. And these are the steps that we're walking you through to create that application. If you have any ideas for an application, let's talk on Slack. Try to do the homework. Ask for help before the end date, before Thursday, so that we can actually help you. And yeah, see you next week. Thank you.